Hello friends, this video on P block elements part 3 is brought to you by examfear.com. No more fear from exam. Now let's talk about the ionization enthalpy. So what is ionization enthalpy? Energy required to pluck one electron. So I have to pluck one electron from here, and the energy required is nothing but ionization enthalpy or ionization energy. So this trend we have seen, if you go from here to here, right, this side, the size of atom decrease, the charge increase, though these electrons are more highly tied to the atoms, to the nucleus here, right? So it's very difficult to pluck one electron here. It needs more energy is required. But if you talk about, let's suppose this guy, it is less energy required. Correct? Why? Because the size is more and this electron is less in control with the barium nucleus. So it's all about the control, right? If nitrogen, if you see in this case, it has, let's suppose, some control over this electron. And if you talk about fluorine, fluorine has more control over its electron because fluorine is more charged and the size of the fluorine is less, so all the electrons are in more control. Simple. So if you compare boron and oxygen also, oxygen has more control over its electron as compared to boron. And if you compare, let's suppose, boron and or let's take this one. Let's take boron and gallium here, right? So here also we see boron has less control, more control, because gallium, the size is very big, right? So this electron is not in that much control of gallium, but this electron is pretty much in control with boron. So it's all comparative, right? So all comparative. So if you see, the moment you go from here to here, the size decrease, and thus the ionization enthalpy, ionization enthalpy energy increase required is increasing. Why? Because the more energy is required to pluck electron. If you go down also, the size of atom increase, the control of nucleus over the electrons decrease, and thus it is easy to pick electron, right? If we go down, so for example, in this case, it is easy to pick electron from this. So the energy required is less, so ionization enthalpy decrease. One thing to note here is that my group 13 ionization energy is less than group 2. Why? So let's take some number. For example, going by this logic, if this was my x, this will be what? X minus some number y. Sorry, x plus some y number. Why? Because let's suppose this was 5 units of energy is required to take out electrons. So in this case, the less energy should be required. Correct? So in this case, let's suppose 4 energy should be required. Or 6, right? Why? Because I told the moment you go from here to here, it requires more energy. For example, it has 1, it has 2, it has 5, it has 6, 7, like that, right? It will increase. So going by that logic, if you see, if my sodium requires X, sodium atom requires X energy to pluck one electron, my boron should require X plus 5 because the size of boron decreased and the charge increased. Correct? See, the size decreased and the charge increased. So here if you go, see, the size is decreasing and the charge is increasing. So with that, the control is more. So it should be like this, but actually it is not like this. This is wrong. Actually, this is 5, this is 4. Why? Because if you see here, my s orbitals are involved, here my p orbitals are involved. Since I have, see, let's suppose these are in 2 are in s, the third one is in p. So since p orbitals are involved, it is easy to pluck electron from p orbitals. Right here, easy to pluck electron from p as compared to s. So the e's will be like this, s will be most difficult, then we have p, then we have d, and then we have the easiest will be f, right? So since the orbitals involved are different here, right? So there is a slight deviation here. So by the general logic, it should have increased, right? The energy required to pluck electron from boron should increase as compared to sodium, but actually the energy required to pluck one electron from boron is less than what is required for sodium. Why? Because the moment you talk about boron, the p orbitals are involved, and it's easy to pluck electrons from p orbitals. Because actually, if you see, this is not the actual shape of the atom, right? Just to simplify things, we have given the shape, but actually the shape of the atom is something like this. We have this nucleus, and we have this orbitals, right? The electron keep jumping here and there. So you have s orbital something like this, p something like this, right? So in this case, if the electron is in p orbitals, it is far away from nucleus, and it's easy to pluck this. But if it is in s orbital, it is somewhere here. It's difficult to pluck electron. So if it is in p orbitals, it's easy to pluck electrons. So the ionization energy is less if you are picking from p orbitals. So just this shift happens only in this case. Why? Because here we introduce p orbitals. So once you have p orbitals, if you compare boron and carbon, there is not much difference because both has p orbitals, right? So the extra p orbital advantage is gone if you compare boron and carbon or carbon nitrogen. But when you compare sodium and boron, the extra p orbital advantage is there, and that's why we have this deviation. Similar thing similar to what we have seen in aluminum and gallium, we have, because here we have d orbital coming into place. This here d orbital was not there. So with extra d orbital, it has some extra effect that was poor shielding, and thus the atomic size decreased. Here also, if you see, with extra p orbitals, it has some extra advantage that the ease of taking out electron from p orbital was easy, so the ionization enthalpy actually decreased. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.